All right, I'm Dave Wright. I'm the founder and CEO of SolidFire. Just wanted to open up briefly explaining what SolidFire is for those of you that may not know us. SolidFire is building an all-solid state storage system designed specifically for large data center clouds. We use a clustered scale-out architecture where we cluster together kind of industry standard hardware over 10 gigabit Ethernet, exporting the storage over iSCSI. And we do this on massive scale, potentially up to 100 nodes over a petabyte of capacity, millions and millions of IOPS, designed to power some of the largest infrastructures as service clouds in the world. But also important to note that it's been designed to be very cost effective. This is not a storage system that was designed only for high performance applications, only for the top 1 or 2% of applications. This is a storage system that was designed to run massive numbers of everyday applications in large cloud environments. So a very different approach than a lot of the other storage systems that you may see here today. 4 main areas of focus for us, and really 4 big places where we differentiate our technology from other storage systems out there. The first is that cloud scalability, the ability to start with a small cluster of nodes and then grow it to massive amounts of capacity and performance. But beyond that, the functionality within the system to host thousands and thousands of applications at the same time and deliver them lots of performance, as opposed to delivering all of that performance to 1 or 2 applications in an enterprise data center. From a performance perspective, obviously we've got a lot of performance, but our focus on performance is very unique. Our focus on performance is not delivering 1 million IOPS to a single Oracle database. Our focus is delivering thousands of IOPS to thousands of applications at the same time and being able to guarantee that performance in a cloud environment and actually being able to control that performance and give guarantees on performance even in a shared multi-tenant environment. Third area of focus for us is efficiency. Again, we want this to be a cost-effective storage system for large storage environments, and so we've designed the storage system to run at high levels of utilization and to use data reduction technologies like compression and deduplication to give you more effective capacity. And finally for us, and this is extremely important in these large cloud environments, is a focus on automation, designing the system to be highly automated and to be used in a highly automated fashion, controlled via REST-based APIs. Anyway, this is SolidFire. This is what we focus on. I'm now going to shift and talk a little bit about what SolidFire's vision for solid state storage, what our vision is, and where we think we go from here. So everybody knows that solid state storage and SSDs are fast. That has been the primary message around solid state storage to this point, is that it's fast. It's a lot faster than disk. Everybody knows that it's fast at this point. Lots of people are building solid state storage systems that are very fast. The question is, where do we go from here? We've got a lot of performance, but what good is performance without control of that performance? And what I mean by that is, if you look at the predominant usage of solid state disk today, it's as a cache or a tier in a storage system, or even host-based caching or tiering. And I want to contrast that with how SolidFire views the control of performance in solid state storage. So from a tiering or caching perspective, I think most of you are familiar with how that technology works, but basically a storage array or a software product identifies the hottest data, looks at the most commonly accessed data, caches that in flash instead of disk, and serves that up to 10 times faster than what it would be if it was coming off of disk. This is a reactive process. It really works on historical information, looking back at access trends, trying to guess what's going to be accessed next. It's also fundamentally an unpredictable process. Because the storage array is making these decisions, applications themselves don't really know what's going to be cached or what's not going to be cached. And so there's a lot of unpredictability in terms of the performance that you may get. And in a multi-tenant environment where multiple applications and multiple virtual machines are contending for that same cache pool, that unpredictability extends over a course of days or weeks, where new applications that are coming into that cloud environment or into that virtualization environment are going to affect how that cache or tier of storage works differently, and other applications are going to see their performance change as a result. And that's part of the reason that this is difficult to monetize in a cloud or a service provider environment, or difficult to charge back in an enterprise environment. Trying to understand which applications are using that flash, how that's going to change over time, being able to give them guarantees about the amount of flash that their application is going to get. These are all very difficult things, because at the end of the day, the storage array is making the decisions about who gets to use flash, which blocks are in flash, based on usage information. It's optimizing for its global view of the world as opposed to individual applications and their behavior. So at SolidFire, we've decided that fundamentally, because of these issues, caching and tiering is probably a stopgap solution. It's not how Flash is going to be managed eventually. We think ultimately the way that you want to manage performance with solid state storage is through something we call performance virtualization. And the idea of performance virtualization is very similar to the idea of storage or capacity virtualization. You know, capacity virtualization is what every storage array does. You get a big pool of capacity and you divide it up in arbitrary chunks to your different applications. Performance virtualization works much the same way. You aggregate all of the performance of all of the flash in your storage system into one big pool, and then you divide it to individual applications, divide it for individual volumes, and then set that level of performance, set that allocation of performance to each of those volumes, and guarantee it on an ongoing basis. The result of this is that performance management is now a proactive activity. It's something that you can set and guarantee to an application up front, but then adjust over time as needed. If an application needs more performance, you can turn the dial, turn it up, and give it more performance. But to the perspective of an individual application, what they see is consistent, predictable performance day in and day out, regardless of other activity that may be going on in that storage array. One result of this is that applications that previously couldn't deal with that unpredictability of performance can now run in these storage environments. So people can move applications off of dedicated storage hardware into shared multi-tenant enterprise clouds or public clouds and be able to run them with a lot of faith that they're going to be able to get the performance they need because of the capabilities of performance virtualization. Another result of this is that performance is now a quantity that's easy to monetize if you're a service provider or easy to charge back for if you're an enterprise. You can set a price on that level of performance that that application is getting, and you can charge a customer for that or charge a business unit for that. And if they need more or less performance, you can turn the dial and charge them accordingly. So performance is now a quantity like CPU, like memory, like disk capacity that can be measured, monetized, and charged back. And that's very different from how performance is thought about today. So I just want to present this as a way that SolidFire thinks performance is going to change in how solid state storage is used today versus how people think about it in the future. So the second thing I want to look at is what good is all that performance that solid state storage gives you without being cost effective? And of course, where we see flash being used predominantly today is the highest tier of applications, the most performance sensitive applications, the places where really performance at any cost is key. But really, if flash is going to expand to encompass more and more of the applications in the cloud or in the enterprise data center, it's got to be cost effective. And certainly one way to do that is through data reduction technologies. Things like compression, deduplication, thin provisioning obviously create huge capacity savings and effectively deliver storage much less expensively and can be very transformative to flash. Why are these things so hard in primary storage? Obviously, thin provisioning has been around for a while. Compression, deduplication has been around in backup forever, but it's very new when it comes to primary storage. Very few people have implemented this, and even fewer have done it very well. So why is it so hard? It really comes down to the architectures of the storage arrays that were built for disk. And if you look at how these storage arrays were built, they were really built around this idea of capacity virtualization. You get a big pool of disk, you carve it up into LUNs, and you export it over the network. And they were designed with a very simple mapping scheme where they map virtual address space to physical blocks on that disk. And there's been some advancements in that over time. We have sub-LUN management now where they manage chunks or extensive data and can move them to different tiers of storage. But fundamentally, there's a one-to-one mapping between this virtual block and a block on disk somewhere. And that really messes up the algorithms that are needed for compression and deduplication, where blocks are variable size, blocks may not even exist, blocks are shared between different volumes. That creates a huge problem, and it's one of the reasons these features have been so difficult to implement in traditional storage arrays. So SolidFire's architecture, and really what we see storage arrays moving to in the future, is an architecture that separates information about volumes and the metadata of which blocks belong in those volumes from the actual storage of the data. And this is a kind of a snapshot of our architecture where we've separated those two pieces out, separated individual information about volumes from the storage of blocks of data that are contained in those volumes. And the net effect of this is that we can optimize the storage of those blocks using compression and deduplication in a way that doesn't affect the mapping of individual blocks into volumes. That's all contained into the metadata. And so fundamentally, this leads to a change in how storage arrays are architected to be able to take advantage of these features. if you look at solid state storage, it's really ideal for these types of data reduction, much better than disk in a lot of cases, because it can handle multiple parallel random reads, the type of read activity that you get when you compress and deduplicate data. You're already doing wear leveling and failure management in managing solid state storage, which means you already have very advanced space management algorithms. And the low latency of solid state storage makes management of the extra metadata you need for these features very easy. But really, this is only easy if you've designed a storage system around solid state. If you've taken one of those legacy architectures and put solid state in it, you're not going to have all of these benefits right out of the gate. There's a lot of work that needs to be done, a lot of re-architecture that needs to be done to take advantage of these data reduction features with Flash. But in the long run, we think that's ultimately where it goes. That's how Flash becomes cost effective for a much wider array of applications. So finally, I want to talk about what good is performance without scale. And again, this comes down to the fact that you see Flash being used in very small niche areas right now, places where there doesn't tend to be a lot of actual Flash capacity. It's just a cache or a tier on top of disk, or it's used as a dedicated storage for a relatively small amount of data in a PCI card in a server, for example. But ultimately, I think all of us want to see Flash used at larger and larger scale. And the interesting thing about Flash is, let's look at the data center metrics that matter. Let's look at a modern data center and understand the metrics that matter to them when they look at their storage, and understand how that affects Flash and how Flash can help with those metrics at scale. So there are certainly some metrics that everybody knows about, everybody talks about: dollars per gigabyte, dollars per IOP. These are the things that are most commonly discussed when people are talking about storage and storage performance. There's another one that people don't tend to talk about as much, but I think is extremely important, and that's IOPS per gigabyte. And really what that talks to is the ratio of performance to capacity in a solution. And the reason this is so important is because you have disk today, which has a very poor ratio of performance to capacity. You just don't get that much performance for all of the capacity that you get. And then you have Flash, which has a relatively high ratio of performance to capacity. You get a lot of performance, but you don't get as much capacity. The problem is most applications fall somewhere in the middle here. They don't always need screaming fast performance, but they need more than what they can get for disk. And this metric of IOPS and capacity is one of the things that makes it extremely difficult for data centers to justify moving large parts of their data center to Flash, and they're trying to figure out how to balance Flash and disk. And I'll talk more about how I think that's going to happen, but this metric ultimately is one of the most important things that I don't think is talked about enough. The last set here are things that when we talk to large cloud computing customers are things that they bring up, things that really matter to them that most people aren't even aware of. So things like gigabyte and IOPS per watt. How power efficient is the solution when you look at the capacity and performance that it provides? Because power and cooling are such a huge part of data center operating expenses. Things like revenue dollars per square foot. In a cloud environment, it all comes down to how much money can they make off of each square foot of space. And they will put in whatever hardware, whatever infrastructure, whatever software product in that square foot can make them the most money. And so if you can find a way to make them more money with Flash than they can make with disk, even if the cost is higher, that is a metric that is extremely important, especially in the service provider and cloud space. One funny metric that most people have never even thought about is terabytes per pound. How heavy is your storage? And we have a cloud computing customer that literally had to reinforce their data center floors with I-beams because their disk storage was that heavy, and they had huge cost in just making their data center be able to hold all that capacity. But there's all kinds of interesting metrics out there that people look at. The interesting thing I think about these metrics, though, is that if you look at where disk has an advantage versus Flash, disk has an advantage there, dollars per gigabyte. Every other place, Flash has the advantage. Every other metric that really matters to people, Flash has a huge advantage over disk. So that brings the question of where does that leave disk? And I would say that I really see storage converging into two tiers. A capacity optimized tier that's a scale out architecture using object or file based storage, using very cheap large capacity SATA disks, used for backup, archival, logging, media storage, anything that really just cares about capacity. And a performance optimized tier. A tier where you are looking at applications that need performance. Not all super high levels of performance, could be a wide range of performance, but performance is important to these applications. This is typically going to be block-based storage. I would say that very soon it's going to be all solid state because of the advantage in the metrics that we talked about there. So this is where your virtual machines are. This is where your SQL and NoSQL storage is. ERP, CRM, everyday business and business critical applications live on this type of storage. It's where your data processing is done before it's shipped off into your archive. I would also say that this type of tiering will not be done at the storage array level. We talked about the issues with storage array caching and tiering. Ultimately, I think this is an application level of tiering. And what I mean by that is an application will understand fundamentally far better than a storage array what its data is and what its characteristics are and where it should be placed. Should it be placed in a disk-based object store, or should it be placed in high-performance block storage? And what level of performance does it need from that block storage, and how can it get that level of performance through performance virtualization? So ultimately, we see the world converging into two tiers of storage, and those tiers being managed at the application layer rather than at the disk layer. So that's it for my message. I really just want to point out that performance is just the beginning. Without control, without efficiency, and without scale, Flash is never going to achieve what everybody, I think, here wants it to be. Thank you very much.